Okay, we're recording.
All right.
Welcome to your technical interview. My name is Kenny. What's your name?
My name is Ed. What time is it?
It is 6:23.
Cool. I asked that for no reason at all. Cool.
Okay, so let's get started with your interview. My main question for you is, could you implement a queue using two stacks?
Like a queue data structure, like it has like a pop and a
Yeah.
okay. Do we have any examples? Any test cases?
So essentially you're gonna write a method that takes in data, and within that method you're going to use two queues, and depending on what the user wants from, I guess, like whether they want to in-queue data or dequeue data.
Wait, are we gonna use? I mean, two stacks.
Yeah, you're going to use stacks as a
So-
queue.
Okay. To simulate a queue.
Yeah, to simulate a queue.
Yeah. So on Q2,
So yeah, one
Q3.
explanation. So
And then
here.
DQ we get 2,
Mhm.
3. Okay. What's the second example, if I can see?
Yeah. So this is one of the test cases. Essentially, if you have
Oh, negative one.
yeah, if you DQ and you are DQing an empty,
Like nothing.
like an empty queue, nothing, just return it around.
Negative one. Okay. Cool. Are there any constraints? Is it always an integer?
For this example, we're only going to do integers, and the
Okay.
values of those integers are just going to be between 1 and 100.
Okay, 1 in 100, so not including 0. Got it. Cool. So let's see. We just want to simulate a queue, so this could be like a void function. Or
Yes.
Recruiting a class.
It depends what the void is for. If you're like in queuing something, you don't need to return anything. But when you're dequeuing, you need to return the last value of the queue.
Okay, cool. So just let's start drawing this up. So 2 queues. I'm just gonna call this. Oh, sorry, 2 stacks, A and B. So anytime we get a thing, let's say this is 40, and then let's say we get 20. So what we really want to do is so how do we simulate a queue is that what we want to do is that whenever we run a DQ function, the function DQ, we want to get 40 out of this. So let's see what happens if we do, I don't know, let's just another input 10. So as of right now, I'm thinking that we want to move so we can select the top of a stack because that we're using stacks to make a queue. So we have like what stacks have the top, right? Is that right?
Yeah, there's top.
And then pop, push. That's all I think. Yeah, top is like the same as peak or whatever. Yeah. So let's see. If okay, we're always popping the ones on top in a stack. I'm just gonna write stack. what if we, so when it came to 20, what if we move this here whenever we get a second input? We can check for the size. That's one of the things. So I'm gonna get 20. Now let's say we wanted to do DQ. So Q functions. I'm curious. You feel like I'm going the right way?
I think you could get a correct answer from the solution, but I already see an easier way to do this problem. And I'll give you this hint. Moving 20, just 20 into stack B.
This is like before we did 10. I'm just kidding.
Yeah. You really don't need to do that, to be honest.
Because the thing is, like,
yeah, so basically
we can only pop the top, so we only have 40 and we have 20. For a second I was thinking, I don't know. But like I was thinking maybe we can constantly pop from only one specific stack.
what would I'll give you a hint as a question. What would happen if you moved all the values from one stack to the other? Just by popping.
It'd flip it.
Yeah.
Wait a minute. I'm just gonna and let's do this other stack. So 1, 2, 3, 4, 5. And now if we remove all these stacks, that would be constant 5, 4, 3, 2, 1. Wow. Let's see. Then we can pop this, and then we can return it back into there. And so then we have something like. I'm just gonna redraw. The next step is gonna be alright. So boop, popped. We'll say A, stack A and B, and then we're gonna return it back. So 2, 3, 4, 5. All right. This is pretty interesting. I have an idea about how to go about this. That was an excellent hint. Oh my god. Yeah, that's how we access. Okay, cool. I'm ready to start writing the function. So let's see. The function NQ. So I guess we can start with in main, right?
I don't think you don't really need to make a main, just make the functions that would like perform this.
Okay.
So just imagine in main that you're just writing like Q
So the function
or
would probably
NQ and
the functions would probably take in both. Oh wait. Would it take in both stacks? Or in here it says that it just says NQ and DQ.
yeah. So really those are just two separate methods. It doesn't have to be one.
Right. Yeah. But like it doesn't. When it takes in like the number parameter, it doesn't take in like the two stacks as a parameter.
No, it's not taking any the stacks as a parameter. The stacks are a part of the function. I guess. Yeah. Actually.
Oh. Wait. Because how are we gonna keep the data?
Yeah, actually, I think for this example,
It's probably gonna be like we can do like stack
hold on.
stack dot like it'll be like stack A dot NQ. And
I wrote a few notes about this.
and stack.
Oh, okay.
Because it makes sense. Like whenever in a queue you're doing like let's say like a normal queue, you're doing like, let's say you have a queue called K, you're doing K dot NQ, K dot DQ. So that does make sense, and not just by yourself. You have to call it from a specific thing.
Yeah.
So it would make sense if we do like stack A dot NQ or dot Q, DQ, right?
Not exactly. There's an easier way to do this. I think just think a little broader than like a function. What are functions and methods under?
Class. Okay.
And then a class can have certain attributes.
True. Okay, so we can create a class. Is it asking us to create a class, or is it was
You can make a class.
okay? I'm not so sure if I should make my stacks public or not inherently. Let's see.
I don't think it should matter because in like the main, you're not interacting with the stacks. You're interacting with an object.
Of this thing. Okay.
And then you're calling methods to the object.
So we can do something like this. By the way, I'm curious, how much time has passed so far since this interview?
It has been 12 minutes.
All right, cool. Class. Let's see. Sim Q. We can have it's gonna have stack of type int A, comma B. We're doing two things in this class. And yeah, public. We're gonna do NQ and then DQ. That's all there is. Got it. That's it. I believe this is all that's needed, right?
Just say, actually, I'll let you go ahead.
What's up?
Yeah, let's go ahead.
And main. Pause it recording.
Hi, we have this room reserved.
Okay, cool. Thanks. Cool. Hi. Resuming our interview. We had a class. Sim Q, where it had two stacks of type integer. And then we had two functions or public. That way we can only call these functions if they were public, right? In main. Can we?
Yeah.
Okay. So if they were private, we couldn't call them.
No, because whether you're private, you can access them.
Gotcha. NQ. EQ. Good. Yes, this was what we had. And then all right. Now time to write them out. NQ. Basically does for wait, it is gonna do, how do you place, what's the function in stacks for placing on top of this thing?
You mean push?
Push, yes. So push, all right, you do A, oh, and then we're gonna take in a variable x, NQX, Oh, so I guess int x. I should specify what we're dealing with. Int x, int x, right? And then over here in our definition of it, we basically have a dot push x. That's it. And our DQ function DQ int. Oh, this is int. We don't even have like a parameter in this. This is I'm going to erase this for a second. We're gonna DQ, and it's gonna be okay, I got it. So what we're gonna first do is that we're gonna grab the size of the stack A, because I feel like I want to do a for loop, but like anytime we're gonna like for example we do like it's I equals 0 and stuff, and then like I is less than like A dot size or whatever, the size is gonna change over time, so we're not gonna actually like be able to get all the values. We're not gonna be able to like move all the values from one stack to another.
Why not?
Like
You technically should be able to.
like if we got like 1, 2, 3, 4, 5, and then we do something like this is A and this is B stacks. So we do something like 4 int I equals 0. I is less than A dot size. I guess we do a while loop. That'll be better. While A dot size is not equal to 0. Yeah, and that'll be helpful. I was thinking about creating like an integer. Yeah. Okay, never mind. We're using a while because that'll be good. While A dot size is not equal to 0. Okay, what happens if it is? If it is 0, let's hit that case first, and then we do an else, and then we'll do that, right? If A dot size is equal to 0, and then we print out -1. Else. Now we're gonna do the big thing. Let's go. While A dot size is not equal to 0. Okay, I want to pull up this chart. How does it look so far? All right, let's go. It said like on interviews, it breathes. Not like you pick like these. Whatever. Sorry. Let's see. We're gonna do B dot push A dot top. Yeah. Or top, right? I say like top is a function of like a stack. Like where you guys see the top of it?
Yeah.
Oh, I guess
What you
like
could
A dot
do
pop.
is you don't need to I guess like keep both of them full at the same time.
Yeah.
Yeah, because if you did top, then you would have two full stacks. A and B would both be full. If you use pop, you would empty A and you'd fill B.
At the same time, yeah. Thanks. Yeah, because pop is gonna give a results, and so we can push that results immediately. All right, cool. And then after this while loop is done, we're gonna do B dot let's see. Oh, I guess like yeah, this is void, and this does not return anything either. So it's a NQ is a void as well because it doesn't return anything. We're just putting it in the structure.
Yeah, shouldn't return. What do you think? You're right about NQ, but I think about DQ.
Oh,
Because if you're DQing,
because we're returning a number. So thanks. Yeah, I was thinking about printing a number like that. So I guess instead of print, I do return. B dots. Okay. Hold on. If we return we do return B dot top, the function ends. So if we do return B dot top, the function would end. So I feel like I have an idea. We can initialize an integer that stores the top, and then we can pop the top, and then we can revert it back, put it back all in A. After we're done putting it back all in A, we do return the integer.
that should work.
Yeah. All right. Alright, so outside of this while loop, we have int result equal to b dot top, and then so let's see. I'm curious, how much time has been going on? Probably like since we resumed
It
recording.
was like
Probably.
I think we're about like 20-ish minutes. I'd say go for another 5.
Okay. Let's see.
Actually, just go for another 2 or so, and then we can debrief and be done.
Okay. So I'll do this, the rest of it, of course. That's always been planned. And then so let's see. Then we do another while. B dot size is not equal to 0. We can do A dot push. B dot pop. The mirror version of this. And then yeah, that's pretty much it. And then outside of this while loop, we're gonna have
One thing you need to consider is
we're gonna we have to do A dot top because we're gonna remove this again.
yeah,
Yeah.
but you could remove it earlier.
Oh wait, yeah, wait. This is DQ, so we have to revert. We have to do this one. So we
Just
can
like
do
with
we can insert pop between these two lines.
Or you could I just have it. You could, your top function's kind of irrelevant. Because if you just do b dot pop, it removes that element you want from your stack and it gives you that value.
Okay, so we should just do b dot pop right after we get the results, and then we can put it all back on A.
You just do b dot pop.
B dot top pop.
No, b dot pop.
Yeah, like between these two lines.
No, just replace top with pop.
Oh, yeah. Thank you. Yeah, because pop returns an integer. And then we just return results. And this is outside the while loop, still in the else statements. All right, I believe this is it.
It looks solid to me. I think you did a really good job asking good questions and being able to use that information to make a usable solution. Yeah, I think the only thing that you could work on is just maybe just like, actually, I don't know. I think you did a really good job.
I did miss
I
the
think,
fact that we are returning numbers. I mean,
yeah, I
I
think,
mean, instead of like, I feel it's kind of interchangeable whether we return or we print out a number.
mhm.
Yeah.
I think one thing you should consider for, I guess, like future interviews is the time complexity of your solutions. Just because there are many ways to solve this problem, but I know one way specifically is like really low time complexity. So I think your algorithm works, but it could be optimized better.
Yeah, I'm not so sure about how I can optimize it better, but let's see, because as of right now, this goes through n at least once, and then another time again, basically, like n minus one again. So approximately 2n, which goes down to O of n. Yeah, I'd be curious about like how we can like make this a bit more simpler. Is it a like is it not O of n?
For your implementation,
No,
you're
for like the implementation, like the how can
the O
optimize
of n, you did it kind of different to how one of the solutions did it, but it was O of n for NQ and O of 1 for DQ. But I think you just reverse them.
reverse them.
I don't think you need to worry about it. I think you did it right. And I think your time complexity is good.
Okay. Cool.
Yeah. All right. But I think we're good.
Thank you.